Okay, in this video, we're going to talk about the converse of the Pythagorean theorem. So we're going to talk about some Pythagorean triple combinations that could be shortcuts to avoid some computations. And then we'll also talk about a way that we can use the Pythagorean theorem to check to see what type of triangle we have. If it's not right, we'll be able to tell if it's an obtuse triangle or if it's an acute triangle. So let's see what we got. So here we want to test to see if we have a right triangle. So if we do indeed have a right triangle, a squared plus b squared will be equal to c squared. And the only thing we need to do is make sure that the longest side always goes with the c. Now for this one, we've got two 7s, so one of the 7s is going to be a c. And 34 is going to be a C, and 6 is going to be a C. The other ones are A or B. It's kind of arbitrary which one. Let this one be B, let this one be A, let this one be B, let this one be A. But what we're doing is testing all of these is 16 squared plus 30 squared equal to 34 squared. So for the A section, it works out. 256 and 900 is 1156, and that's the same thing as 34 squared. So yes, this one is a right triangle. If we look at 3 squared and 4 squared, 9 and 16 is 25. That's not the same thing as 36, so it's not a right triangle. In fact, we're going to see that if a squared and b squared is less than c squared, actually what we have is an obtuse triangle. There's this opposite idea. If it's less than c squared, we have an angle that's bigger than 90 degrees. So we have an obtuse triangle, but it's not a right triangle for this section. And if we do the same thing for C, 1 squared and 7 squared is going to be 50, and that's bigger than 49. And in this case, we have a squared and b squared is bigger than c squared, which means we have an acute triangle with all angles less than 90 degrees. But it's not a right triangle. Okay, so this is kind of previewing what's coming up. So let's look at these. We're going to do the evens again. Go down the other page. So we're checking, is 20 squared plus 21 squared equal to 29 squared? If it is, we have a right triangle. So 20 squared and 21 squared is 841. And 29 squared is also 841. So this is a right triangle. Okay, we want to check number 4 is 0.8 squared plus 1.5 squared equal to 1.7 squared. 8 squared is 0.64. 1.5 squared is 2.25. And that adds up to 2.89. And 1.7 squared is also 2.89. So here we have 2.89 equals 2.89. Yes, this is a right triangle. Okay. Now here we have some Pythagorean triples. The 3, 4, 5 you should be aware of. You've seen these before. So if you see like a 6, 8, 10, that's a basic 3, 4, 5 because you can take a 2 out of each one of these. Or if you have a 9, 12, 15, you can take a 3 out and get your basic 3, 4, 5. So let's say you have 9 and 12 and you saw that pattern, and you realize that that's the same thing as a 3 and a 4 when you take the 3 out of both of those. So the 5 is the one that's missing. 3 times 5 gives you the 15. You can get the 15. Another good one to know, they like to use this on the SAT, is 5, 12, 13. 5 squared is 25. 12 is 149. That gives you 169. This is a pretty common one because it's not as obvious as the 3, 4, 5 one. Also, the multiples, these aren't so easy to see, but the multiples, you could do the same thing that we could do with 3, 4, 5. 8, 15, 17 is another Pythagorean triple. 8 squared plus 15 squared is equal to 17 squared. So if you recognize that, or you have this chart available, like if you're given an 8 for one side or one leg and a 17 for the hypotenuse, you know the other side is going to be a 15. Or let's say you were given a 34 for the hypotenuse and a 16 for one of the legs. You know that 30 has got to be the other side. So that's how these can be used. And then 7, 24, 25 is another one. So if you can remember, especially the 3, 4, 5 one and the 5, 12, 13, that will save you some time on computations. Okay, let's look at number 6. So use Pythagorean triples to quickly find the value of x. So here they're given us a 34 for the hypotenuse and a 16 for one of the legs. If we look at the chart, 34, 16, 30 is the missing leg. Look at number 8. We get a 65 and a 25. So we don't see that obvious on here, but let's see what we got. If we take a 5 out of this, we have a 5. And if we take a 5 out of this, we have a 13. And so what do we have with a 5 and a 13? This one here, 12 is the one that's missing. Now we took a 5 out, so 5 times 12 is going to be 60. So the missing side is 60. Let's look at the next page. Here we're going to use the converse, which is really using a squared plus b squared is equal to c squared to test and see if it is a right triangle, or if a squared and b squared is greater than c squared, we have an acute triangle, or if a squared and b squared is less than c squared, we have an obtuse triangle. So let's look at what they're doing here for example 2. We get 8, 12, and 13. So 8 squared is 64. 12 squared is 144. That gives us 208. 13 squared is 169. So we have a case where a squared and b squared is greater than c squared. That means we have an acute triangle. So if it's a greater than, we have all angles that are less than 90. Acute triangle. Let's look at B. We got 4, 4, and 7. 4 squared is 16. Another 4 squared is 16. That gives us 32. 7 squared is 49. So we got 32 versus 49. 49 is greater than 32, or 32 is less than 49. Since it's less than, that means we have an angle that's greater than 90. It's this opposite idea. That means we have an obtuse triangle. So that's pretty much what we're going to do when we look at these others. So let's look at number 10. Root 5, root 10. So a squared, root 5 squared is a 5. Another root 5 squared is another 5. That gives us a 10. And root 10 squared is a 10. So here we have 10 equals 10. This is going to be a right triangle because it's equals. Let's look at number 12. For number 12, we have 5 squared, which is 25, plus 7 squared, which is 49. Altogether, that makes 74. And we have the root of 74. Square root of 74 squared is 74. This is another equals. This is a right triangle. Let's look at number 14, 8, 11, and 15. 8 squared is 64. 11 squared is 121. This gives us 185. And 15 squared is 225. So 185 is less than 225. That means that this must be an obtuse triangle. And the reason it's obtuse again is it's the opposite idea. If the a squared and b squared is less than the hypotenuse squared, then one of the angles is going to be greater than 90 degrees. Let's look at number 16. 5, 5, 5 root 3. So 5 squared is 25. Another 5 squared is another 25. That gives us a 50. 5 root 3. Now 5 times 5 is 25, and root 3 times root 3 is root 9, which is 3. So we have 25 times 3, which makes 75. So 5 root 3 squared is 25 times 3, which is 75. Now, a squared plus b squared for this one is less than c squared. That means this is going to be an obtuse triangle. Okay, let's look at number 18. Diagrams are not drawn to scale. Which angles would be right angles? Let's look at this. So they're giving us some dimensions here in this triangle. Here's a 5, 12, 13. That tells us that this is a right angle because this is a Pythagorean triple. 5 squared plus 12 squared is equal to 13 squared. We can go back up and look at our list here if we don't remember it. Here's our 5, 12, 13. So that's a Pythagorean triple. We know we have a right triangle. Now, by vertical angles, this angle is going to be right. By linear pairs, these are all going to be right. We actually have a rhombus here. We've got diagonals that are perpendicular to each other. It's got to be a rhombus. And if this is a 13, then these are, well, let's see, 12, 12, 5, 5. So the diagonals aren't congruent. So it's not going to be a square, but it is going to be a rhombus, which means that all the sides are going to be congruent. So these are all going to be 13s and so on. Which angles would be right angles? So all these angles here at I would be right angles. Angle EIH, angle EIF, angle FIG, and angle GIH are all going to be right angles. Okay, let's look at number 20. So what I see here is a 15, 8, 17. I think that's a Pythagorean triple. Let's go up here and look on this other page and see. 8, 15, 17 is a Pythagorean triple. It means we have a right triangle here. So 8, 15, 17. Now the biggest one is going to be the hypotenuse. That means this is a right angle there. And since this is adjacent, this is going to be a right angle there. Let's see. Down here we have an 8, 20, 25. Let's see if that's a Pythagorean triple. No, we don't have an 8, 20, 25. So this is not going to be a right angle here. But those are going to be right angles. And let's see. And all we have to do is identify the angles that are going to be right angles. So for this one, this angle NQO, and this angle here, this angle PQO, are going to be the right angles. Over here we had like angle FIG, angle GIH, angle EIH, and angle EIF. All were right.